So, good afternoon, everyone. I'm Gaurav Kumar, a PhD research scholar at Department of Design, IIT Kanpur. I'm your uh, course teaching assistant. So, it gives me a great pleasure to welcome you to today's sessions on the summary of the flow method in conceptual design. So, the focus of this presentation is on how we can systematically decompose complex product into a simpler functional elements that are easier to understand, analyze and innovate upon. Okay. So as you can see on the slides that we have a systematic approach to uh, functional decompositions. Okay, so highlights what makes this method so powerful. It is not a random or intuitive but structured, disciplined and repeatable. So this is particularly important in a modern product design where a complexity continues to grow with the integrations of mechanical, electronic and digital technology. Okay. So, okay. So I'm Gaurav Kumar, affiliated with Department of Design IIT Kanpur, and over the course of this talk, I will guide you through the key concept, benefits, and example of the flow method. Okay, so by the end, you will see why this approach has become an essential tool for designers and engineers who wish to bridge the customer needs with technical, functional, in an efficient and innovative manners. Okay. So moving to the next slide. Our next slide is about, yeah, introductions. Okay. So the flow method is essentially about breaking down our complex systems into smaller functional elements. So when we look at a product, we often see it has a collections of physical parts, gears, motors, circuits, chasing. So, however, during conceptual design, what really matter is not the parts themselves, but the functions they perform. So, the flow method help us to capture this essence of what it does rather than what it is. Okay. So, this approach is extremely useful in the early stage of design. So at this stage we don't yet know what the final product will look like or which parts will be used, but we do know what the product must achieve. So by applying the flow method, we can create a functional model that captures requirements without looking ourselves into premature solutions. So in addition, this method provides a clarity and structures. So many innovative ideas fall, they actually fail not because they lack creativity, but because they lack structure and consistency. So the flow method ensures that all requirements are addressed systematically and that no important functions is overlooked. So it gives both a big picture view and a step by step breakdown, making it indispensable for a clear conceptual design. Okay. So moving towards the next slide. So next one is black box approach. Okay. So the first step in this method is the black box approach. So here we treat the product as a black box. So this means we are not concerned about what happens inside it yet. So we only care about what goes in and what comes out. Okay, so we only care about what goes in and what comes out. So it's a way to simplify the system while defining its boundaries clearly, right? So by identifying inputs and outputs, we create a functional contract for the product. For example, for washing machines, the inputs are electricity, water, detergent, and dirty clothes. So the outputs are clean clothes and wastewater. So this way the essence of the machine is purpose is captured without being distracted by the parts. Okay. So the benefit of the black box approach is that we force it forces us to focus on the overall transformations that the product provides. So this shift in focus from components to functions so helps us see the system more abstractly, allowing us to imagine multiple possible solutions. Different mechanism may perform the same functions, and by keeping the box black, we avoid prematurely locking into a single technical choice. Okay. So next is input outputs. Okay, so once the black box has defined, so the next task is to identify all the inputs and outputs. So this step is critically because our functions cannot exist in isolations. So it always act upon something. Input are so inputs are generally categorized into three forms: energy, materials, and signals are informations. So these intents the systems get transformed and then leaves us as outputs. So the outputs include both the desired result and the unavoidable byproducts. So for example, in a car engine, the design output is mechanical energy to move the car, while the byproducts are heat, noise, and emissions. So identifying the both is essential because byproducts often often cause inefficiency or harm, and designers must manage or minimize them. So by mapping input and output, we establish the functional boundaries of the system. So these boundaries definitions ensures that nothing important is left out. A design that misses even one critical input, so like forgetting about waste disposal, will inevitably fail in practice. So therefore, this steps ensures completeness and the prepares the ground of the functional flow mapping. Okay. So now moving towards the next slide. Okay. And so next is the functional flow mapping. Okay. So once input and outputs are defined, we move the functions flow mapping. So here we trace how each input transforms step by step until it became as an output. So instead of focusing on a mechanical or electrical parts, we focus on transformations such as convert energy, uh, transport materials, or process signals. So the beauty of function flow mapping lies in its abstractions. So by focusing on transformations, we avoid getting stuck in implementations details. For example, in a fan, electrical energy becomes the rotational mechanical energy, which is then just to move air. Whether the fan used an AC motor, so or a DC motor, or even a manual crank is secondary. So the flow map captures the essential functions first. So this mapping also makes the relationships between functions explicit. So it helps to identify uh, dependencies, redundancies, and even potential innovations. So when a flow is inefficient or overly complex, it often signals an opportunity to simplify, combine, or redesign functions in a more effective way. Okay, hope this is clear to everyone. The function flow mapping. Okay, now moving towards the next one. Okay, oh, just a minute. So now next is notation and language. So to ensure early clarity across team, the flow method uses standardized notation and language. Functions are written as verb noun pairs such as convert energy, transport materials, or control signal. So this structure force precision, and it avoid vague descriptions like handle, input, or do work which don't communicate much. So the consistency of this language means that diagrams and models can be universally understood when a design team use verb noun pairs. Okay, engineers, designers, and even non-technical stakeholders can flow the logic. So it becomes a common language that reduce uh, misinterpretations and confusion. So standardized notations also allows a functional models to be shared beyond one project. For example, an aerospace company and a medical device company might use the same functional modeling language and allowing knowledge transfer and reuse of design logic. So this is why such conventions are widely promoted in engineering design practice. Okay, I hope the notation and language you get it. Okay, and now next is decompositions into sub functions. Okay, so after building the main function flow, we decompose the flow into sub functions. So this step is where we move from broad definition to finer detail. Okay, and each sub functions represents a smaller manageable piece of the overall task. For instance, the main function of coffee machine is prepare coffee. Breaking this down, we might get sub functions like heat water, grind coffee, filter brew, and dispense liquid. So each of these is clear, measurable, and directly tied to customer satisfactions. So if one sub functions fails, the overall functions cannot succeed. Okay, and decompositions also helps the track dependencies by seeing how sub functions rely on each other. So we can identify critical paths and weak point. So this makes it easier to improve reliability, reduce risk and optimize performance. So without decomposition, complex system would remain unmanageable and design errors would be far more likely. Okay. Now moving to the next visual representations. Okay. So to to make a functional structures understandable, we rely on visual tools. Okay, so functions, trees, flowcharts, and block diagrams are common way to show how sub functions connect and interact. So these diagrams provide a quick overview that is easy to digest than page of text. So one of the strengths of visual representation is that it allows us to spot inefficiency and unintended uh, effects early. For example, a function tree might reveal that process produce unwanted heat, noise or waste. So once visualize these byproducts can be addressed more effectively. So visual models also enhance collaborations. So they provide the shared reference that engineers, designers, and even clients can point to and discuss. So by making functional relationship explicit, they reduce misunderstanding and speed up the decision making process. Okay. So moving to other next one is advantage. So the follow methods offers the several advantages. First is ensures the customer needs are systematically translated into technical sub functions. Nothing is left vague and every requirement is linked to the functional elements. So this systematic relations is vital in customer driven design. So second, the method highlights the area of innovations uh, when some functions are visible. Designers often see multiple ways to perform them. So this opens the door to creativity and novel solutions. For example, transporting the materials might traditionally be done with the conveyor belt, but the alternative solutions like pneumatic tube or robotic arms may emerge during functional analysis. So third, the method strengthens the problem solving by making the system transparent, and it becomes the easier to locate where a failure occur and where improvements will be most effective. So instead of troubleshooting blindly, the flow method directs attentions to the right functions and its related sub functions. Okay. So next is examples uh, application. So let's now look at a concrete example. So an electric pencil sharpener takes in two input, electrical energy and a pencil. So the outputs are sharpened pencil and wood shaving. So sub functions inside convert electrical energy to mechanical rotation. Guide pencil, remove wood and graphite and collect the shaving. So these functions decompositions makes it clear how the overall sharpening process is achieved. Okay, and another example is paint bottling machine. So where input includes the liquid paint, empathy bottles, and sometimes compressed air or control signals. So the outputs are filled bottle and the small amount of residual loss. So make mapping its functions may reveal states such as transport, pen, dispense materials, seal containers, and detect labels. Okay, so these examples demonstrate how the flow method moves us from a broad understanding of purpose to detailed functional insight. So, regardless of whether the product is simple or complex, the process of making input, transformations, and an output remains the same, ensuring that nothing important is missed. Okay, so next, moving to ask the next slide. Uh, so, now this is the summary whatever we have learned in last 1 week. Okay, so to summarize, the flow method is a disciplined approach to conceptual design that shifts our thinking from parts to functions. Okay, so by focusing on transformations and flow, we capture the true purpose of product rather than its superficial structure. So this method ensures that customer needs are systematically addressed and translated into technical subfunction, and it also helps identify unwanted byproducts and opportunities for innovations. So moreover, the clarity and it provides the improves communications between stakeholders and strengthens system reliability. Okay, and ultimately the flow method is not just a modeling tool, it is a mindset, and it trains us to think functionally, systematically, and creatively. So when applied consistently, it results in designs that are not only effective and efficient but also innovative and customer centered, that is human centered. Okay, okay, now we will move to ask the so this was the summary of whole 1 week whatever we learned since last one. It was a quick summary of the week 7. Okay, so functional structure flow method. Okay, so it was the the quick summary. Now we are moving to ask the question answer sessions. Okay, so our first question is, as you can see on your screen, that the advantage of functional common basics are uh, option A, common vocabulary vocabulary of, of functions and flow. B, comparing products across domain is easy. Minimize the customer needs, or major change to product are restricted. What are the right answer? Okay, please pause the video and answer yourself. Then I will also provide a right answers. I will also provide the explanation and the right correct answers. Okay, okay, so the idea of functional common basis is to create a standardized language for describing product functions and flow. So this vocabulary ensures that every designer engineer or researchers working on a project interprets the term in the same way. For example, the the phrase convert energy always means that same transformations, whether in the context of a car engine, washing machine, or medical devices. So this consistency remove ambiguity, improves collaborations, and makes documentations much uh, clearer. And second major advantage is across domain uh, comparability. So by focusing on functions instead of parts, we can compare products from entirely different industries on functional level. So for instance, a blood pump in a healthcare and water pump in households appliance may look very different, but functionally both perform transport liquid. Okay, so by identifying such commonalities, design solutions from one domain can inspire innovations in another. Okay, so therefore the functional composition basis does not restrict design changes or minimize customer needs. It actually enhances flexibility and opens up opportunities for improvement. So the main benefits lie in creating a universal vocabulary and enabling meaningful comparisons across domains. Okay. Now you can also see the expression part on your screen and the correct answer. So the correct answer for this question is option A and B is the right answer, and this is the expression part which you can go through the slide. Okay, so as I have written here, the functional common basic provides the designers with a standardized vocabulary for describing functions and flow. So this ensures that when a different people or teams works together, they have a common language to avoid ambiguity. For example, terms like convert energy or transport material mean the same things to all, regardless of domain. So another advantage is that it allows for a cross domain comparison. Products from a different industries, say medical devices and households applies, can be compared at a functional level. So this highlights the similarities and allows lessons learned in one area to be applied to another. So option C and D are incorrect because functional common basic does not minimize customer needs for restricted product change. Instead, it enhances the flexibility and clarity. Okay, so A and B is the right answer. Okay, moving to ask question number two. Question number two is saying that functional common basic add adds in finding is when functional decomposition should be stopped, correctness of functional decompositions, restricting major changes to product, or secondary functions. What is the right answer? Please answer, and I will also provide the right answers. So in breaking down a product into functions, one one recurring challenge is knowing when to stop the decompositions. So So if we stop too early, the functions remain vague and unhelpful. So if we break them down too far, the process becomes unnecessarily complex. So the functional common basic decomposition. So the stopping point is usually when serve functions are customer driven, measurable, and okay, and independent enough to be addressed individually. So for example, in coffee machine, it is logical to stop at a serve functions like heat water and filter brew. So rather than decomposing further into rising temperature by 1 degree Celsius per second, the function's common basis ensures a balance between clarity and practicality. So this makes the option A correct, while the other are incorrect. So correctness of decomposition is validated separately by customer satisfactions, not by the common basis itself. Okay. Likewise, restricting product changes or identifying secondary functions are outside its scope. Okay, and now you can also see the explanation part in the next slide. You can go through this slide. Okay, please go through this slide. If there is any doubt, you may ask me. Okay, then we'll move to ask next question, question number 3. Okay, next is question number 3. So the question number 3 is asking dash gives the internal decision making capability for our devices. Is it product values, material of the product, informations, energy? What is the right answer? If you can answer, it will be great. Else I will also explain in few seconds. You can give a try. So dash gives the internal decision making capability for our devices. Okay, so information is the critical flow and allow a device to make internal decisions. So it carries signals, commands, and feedback that guide of systems operations. For example, in printer, the informations about the documents to print the color setting, and ink reveals dictates how the device functions without information. So the printer cannot decide when to start, stop, or change its behavior. So in contrast, energy provides the power of operate, and materials represent the physical items being transformed. So both are essential but passive. So they do not allow the system to choose or adapt. So the product value of the other hand reflects the external judgment and are not functional flows at all. So thus information is what transforms a machine into intelligent system, and it is the key enabler of automations, so control and adaptability within product design. Okay, now you can also check the correct answer and explanation part on your screen. Please pause the video and go through this slide. Okay, so the correct answer is information. So as I have written here, the device uh, makes the internal decision based on information flow. For example, yeah, you can go through this slide. Okay, now moving towards the next question number 4. So given below is the black box model of an inkjet printer. Identify the input and output flow. Okay, it's electricity, human force, ink, paper, data. We are giving on or off, and make hard copy of document. So what it produce? Heat, noise, and kinetic output. Print out, printer status, ink level. So what is the right answer? So question is asking, given below is the black box model of an inkjet printer. Identify the input output flow. Okay, so in an inkjet printer, the three flows definition is operation, energy, material, and information. So energy usually electricity, powered the motors and electronics. Materials includes the paper and ink, which undergo physical transformation to produce a printed sheet. Information refers to the digital documents or image to be printed, guiding how the ink is placed on the page. Together, these flow capture the complete functional picture of the printer. So by identifying these flow, we clarify what the system requires to functions and what it produce the output are the printed material and secondary byproducts such as noise or waste heat. So without this functional view, the product may seem like just a collection of parts, but the black box model capture the transformations process clearly. Okay, so options that suggest only informations or signals as a primary input and incomplete, since no device can work without energy and materials. Hence the correct sequence is energy, material, and informations. So option D is the right answer, and you may go through this slide. Okay, please go through this slide, pause your video, and then you can go through this slide. So the correct answer is D, energy, materials, and informations. So as I have given you the very short explanation here, that in an inkjet printer the primary inputs are energy, electricity to power the printer, materials, paper and ink, and informations, the digital documents to be printed. So the outputs are printed material plus byproducts such as heat and noise. So option A is option A is misleading because information is not the first priority and it cannot operate without energy. Option B introduce the signal which is weak in this context. So option C confuse the flow. Therefore the correct flow sequences is energy, material, and information is the right answer. Okay, moving to ask the next slide. Question number 5. So the question number 5 is asking, dash provides a systematic approach for decomposing a product design problem into simpler sub problem. So what is the right answer? Is it product simplification, or is it product disintegration, or functional modeling, or conceptual design? What is the right answer? Okay, so functional modeling is the formal method for breaking down a complex product design problem into smaller manageable sub problem. So instead of jumping directly to physical parts, it focuses on functions, what the product must do. For instance, in an electric fan, functions include convert energy, rotate blades, and move air. So each function is then studied in isolations before linking them together. So this approach ensures that no customer need is left unaddressed. So by systematically mapping input to outputs, so designers can verify that every required transformation is included. So the flow diagram provide a logical structure that minimize oversight and redundancy. So while conceptual design is the broader stage where this happens, so functional modeling is the specific method that brings structure and discipline, unlike product simplifications or disintegration. So it is not about reducing or breaking apart arbitrarily, but about mapping functions systematically. Okay, and now you may go through the right answer explanation part in the next slide. Yeah, so the C is the right answer. Functional modeling is the correct answer, and this is the explanation. You may go yourself. I have written here briefly that functional modeling is the tool used to decompose a product design problem into manageable or functions, and it allows the designers to visualize the transformations from input to output and ensure no customer need is overlooked. So while conceptual design is the broader stage where functional modeling take place, okay, the system systematic approach itself is specifically functional modeling. So the product simplification and disintegration are unrelated. They don't provide structured decompositions. Okay. So next is question number 6. What is the next step after the functional decomposition? Okay. So is it customer requirements, marketing the product, or functional analysis or product architecture? What is the next step after functional decomposition? Okay. So please answer. So once functions are decomposed into sub-functions, so the next task is to translate them into physical form through the product architecture. So this is where abstract functions are assigned to components or models. For example, the functions heat, water may correspond to heat. Okay, to heating and heating coil. So while dispense liquid corresponds to valve or pump. Okay, so this step is crucial because it creates the breeze between functional thinking and engineering design. So it transforms abstract requirements into tangible design choice. So without these translations, the design remains incomplete, stuck at the functional level. Okay, and the customer requirements and marketing happens before decompositions, while functional analysis overlaps with decomposition. So therefore the correct sequential step is product architecture, which moves the design towards physical realizations. Okay, so D is the right answer. And you can pause the video and you may go through this slide. I have clearly written the explanation part here, so please pause your video and go through this slide. Okay. So next is our, just a minute, question number 7. Okay, which of the following is the part of product architecture? Okay, is it physical component, building blocks, product assembly, or functional elements or direct needs? What is the right answer? Question number 7. Please go through these questions. Please pause the video and answer yourself. Then I will also provide explanation part. Okay. So the product architecture defines how a product is organized. Okay, into two models and components. At its core, it's, it involves the mapping functional elements to physical components, ensuring that every sub-function has a physical means of realizations. For example, in a smartphone, the process information functions maps to the CPU, while stored informations map to memory modules. So building block are another aspect of architecture. So they represents standardized until or modules that can be reused across different designs. So this modularity makes the product easier. So the assemble, so to assemble the maintain and upgrade functional elements finally provide the logical link between customer requirements and components, ensuring alignment between what the product must do and how it does it. Okay, and product assembly is more of manufacturing activity, not a part of dealing architecture. So direct customer needs are already translated into functions before architecture. So thus the three true components are physical components, building block, and functional elements. Okay. And now you may see the right answer and expression part in this slide. Okay, so please go through this slide. So as I have written here that physical components, building blocks, and functional elements are the right answer. Okay, and the product architecture links the functional elements to physical components. Building blocks define how the product is organized. Modules, subsystems, and assemblies together. So they shape the product is architecture. So direct customer needs are addressed early in the process. Product assembly C is a manufacturing step, not part of defining the architecture. So thus physical components, building block, and functional elements form the true core of product architectures. So so A, B, and D is the right answer for this questions. Okay, now moving towards the next question. Question number 8. What are the considerations for product architecturing? Is it ability to offer the product variety, or product cost, or design lead time, or all of the above? What is the right answer? Okay, please pause the video and answer it yourself, and meanwhile I will also provide the correct explanations for these questions. So question number 8. This is basically product architectures. The must balance the multiple factors first, and it should enables the product variety. So allowing the different version or models to be developed from the same base design. So this flexibility is often achieved through the modularity. For example, a laptop model may come with a different RAM or storage configurations but share the same architectures. Okay, and the second, cost is a key factor. The way functions are grouped into modules influence the manufacturing expense, materials uses, and even assembly costs. Poorly designed architecture may lead to unnecessarily uh, expensive products. And third, design lead time must be considered. Complex rigid architecture often delay product developments, and simpler modular structures speed up the process, and hence ability to offer a variety cost and design time together define effective architecture. Ignoring one of them weakness competitiveness in the market. Okay, and now you can also see the right answer as D. All of the above are the right answer, and you may go through yourself that and you can read the question part on from this slide. Okay, please go through this slide, and if you have any doubt or anything, you may write email to me, and I will try to get back to you. Okay. Now moving to the next question. Question number 9. Follow method is also referred to as a dash since the box with input and output is used to define the functions of the product. What is the right answer? Is it fast method, system approach, or product approach, or customer approach? What is the correct answer for this particular question? Question number 9. Okay, and I will also provide you the right answers and as well as explanations to you. So the flow method is often described as a system approach because it treats the product as a system of interconnected flow. An input of energy, material, and informations into the system are transformed and exit as output. So this mirror how systems thinking works, focusing on relationships, transformations, and boundaries rather than isolated parts. So this approach is holistic, ensuring that designers look at the entire system, including unwanted byproducts and side effects. For example, in a car engine, not only does it produce torque but also heat and emissions, okay, and which must be managed. While the fast method is another tool in functional analysis, and it flow a different process, product and customer approaches are less prices. Hence, the flow method is best captured as a system approach. Okay. So B is the right answer, and you may go through this slide. This is the explanation slide. Yeah, please go through this slide. Now moving towards the next slide, question number 10. 10 is about dash helps in the early stage identification of product architecture. Oh, sorry. So you must have seen the answer. Okay, so in the early stage of the product design, functional modeling is particularly useful because it exposes the structure of sub-functions and their interconnections. So by examining these relationships, Designers can see natural grouping of functions that suggest possible modules or components. For example, in washing machine, functions like heat, water, and control temperature naturally belongs together, pointing toward a heating subsystem. Similarly, rotate drum and balance load line to form the drive subsystem. So, other two like concept scoring or product dissections came later in the process or are used for competitive analysis. So customer needs are already identified earlier. So thus functional modeling is the right method of for shaping product architecture at the conceptual stage. So now you may go through this slide and you can also go through this explanation part. So please go through this. So moving towards the next slide, question number 11, which of the following is not an input in a functional model? Is it energy, material, information, or customer needs? So in functional modeling, input are strictly defined as flow of energy, material, or information. So these are tangible or intangible resources that enter the system and undergo transformation. For instance, in a microwave oven, electricity is the energy, food is materials, and cooking setting is information are the inputs. So customer needs, while essentials are not a part of the input set, so they are instead the foundation that guides functions creation. For example, the needs cook food quickly lead to function transfer heat rapidly, which is then realized through the input flows. Okay, so thus customer needs are the starting point of design, but they don't appear inside the functional model. They are translated into functions which are then supported by energy, materials, and information flows. Okay, and now you may see the right answer, the correct answer, and the explanation part on your screen. So please go through this slide. So the customer needs are the correct answer, and this is the explanations. So please go through this slide. Okay, so moving towards the next question, question number 12. Okay, so question number 12 is asking that functional decomposition ensures that what? The design is broken down into a physical component directly. Each customer requirement is mapped to measurable functions, or marketing strategy are finalized early, or product cost is minimized automatically. What is the right answer? So, so the purpose of functional decomposition is to bridge the gap between abstract customers' requirement and measurable technical specifications. For example, the need keep coffee hot, okay, and became the functions maintain liquid at 70 to 80 degrees Celsius. So this make the requirement actionable and testable. So by decomposing systematically, designers ensures no requirement is left vague. Each customer demand is explicitly tied to one or more sub-functions. So this alignment improves traceability, allowing teams to check whether all needs are being met. Okay, and it does not directly minimize cost or finalize marketing strategy. So those are later activities. So nor does it immediately create physical components. Its main contribution is turning fuzzy needs into measurable, testable, functional goals. So you may go through this slide. The each customer requirement is mapped to measurable functions, and this is the what explanation is. Please go through this slide by yourself. Okay. Now moving to ask the next questions. Question number 13. Which diagram is most commonly used to represent the functions and flow? Is it Gantt chart, functional block diagram, or Pareto chart, or scatter plot? What is the right answer? So the most common diagram for representing functional flow is the functional block diagram. So here each function is down as a block and flow of energy. So so the material and informations are shown as arrows between blocks. So this creates a clear picture of how the system transform into transform inputs into outputs. Okay, so these diagrams are versatile and can capture both high level black box models and detailed subfunctions decompositions. So they highlight our relationships, dependencies, and flow directions, making the system easier to analyze. So other chart like Gantt or Pareto are valuable but serve different purpose. So Gantt chart are for a project scheduling, Pareto charts for prioritizations, and scatter plots for data analysis. Okay, so none of them capture a functional flow as a effectively as a block diagram. Okay, so the correct answer is functional block diagram. Option B is the right answer, and you may go through this explanations part. Please go by yourself to it. Now moving towards the next slide. Question number 14. So in the black box model, unwanted byproducts such as heat and noise are classified as input, output, surfactant, or constraint. Question number 14. What is the right answer? Okay. So in a black box model, unwanted results such as heat, noise, and vibrations are classified as outputs. So even though they are not a desired, they are still consequences of the transformations occurring inside the system. So for instance, in a laptop, while the intended output is processed, information heat is also generated and must be managed with cooling fans. Okay, and recognizing by products as outputs helps the designers address if inefficiencies. So once they are visualized in the model, strategies can be created to minimize, recycle or eliminate them. So this makes the system more efficient and user friendly. So these byproducts are not input, since nothing enters the system as a noise. They are not a sub function because they are not a deliberate the transformations, nor are they constraints. They are output that need management. Okay, so the right answer for this particular question is option B, outputs is the correct answer. Now you may go through this slide by yourself. So please go and read the small explanation part. Hopefully it will be really helpful for you guys. Okay. So moving towards the next questions, question number 15. So question number 15 is asking about the flow method helps in innovation because it reduce the number of customer requirements, it focus only on cost reductions, or it show multiple way to achieve a function, or it avoid decompositions altogether. What is the right answer? Can you answer? The flow method, okay, let me provide you the explanation. So the flow method foster innovations because it focuses on functions rather than fixed solutions. So by breaking a product into functions, designers can see that each functions may be achieved in a multiple ways. For example, transport materials could be done by conveyor belts, pneumatic systems or magnetic leviations. So this this speaks creativity and open the door for novel solutions. So innovations often comes from rethinking how functions can be realized by decoupling functions from a specific part. The flow method encourages cross dominance inspirations. Solutions in one industry may be adapted in another because the function is the same. So therefore, unlike reducing requirements or focusing only on cost, this method actually broadens possibility. Okay, and it is precisely the process of decompositions and making that makes innovations possible is the right answer. Okay, so the correct answer for this question is so multiple ways to achieve a functions. So as I have given you the explanation, that by breaking down a product into four functions, the flow method makes it clear that each functions can be realized in a different way. For example, transport materials could be achieved with a conveyor belt, pneumatic tube or robotic arm. This opens up opportunities for innovative solutions. Option A and B are limiting perspective. Innovation is not about reducing needs or focusing slowly on cost, and option D is wrong because decomposition is central to the method. Okay, so C is the right answer. So moving to ask the next question, question number 16. So which of the following is immediate benefit of using common functional vocabulary? Is it faster market campaigns, reduce need for prototype types, or better communications among design teams, or lower manufacturing cost? What is the right answers? Okay. So basically Standardized functional vocabulary ensures that everyone on the design team speaks the same language. Verb noun pairs like convert energy or guide material, okay, are precise and universally understood. So this avoid the vague term like handle input, which can mean different things to different people. So the immediate benefit is clear communications among team members. The multidisciplinary projects, say involving mechanical, electrical, and software engineers. So this common vocabulary eliminates the misunderstanding and speeds up collaborations. So while reduce prototyping and lower cost may flow later, the first and most critical impact is better communications. Clear language ensures alignment and makes a design process more efficient from the beginning. So yeah, now you may see the see the right answer. Better communication among design teams is the right answer, and you may go through this explanation part by yourself. Okay. Now moving towards the next slide. Question number 17. Okay. So product architecture translates the customer needs directly into profits, functional elements into physical components, or business plans into prototypes, or energy flow into financial models. What is the right answer? So the essence of the product architecture is mapping of functional elements into physical components. For example, the function store energy translate into a battery, while convert electrical to mechanical energy becomes a motor. So this mapping ensures that the abstract functions are realized in tangible form. So this process bridges the gap between conceptual design and detailed engineering. So without this translations, the design would remain the theoretical and could not be manufactured. Okay, so the other options listed, the profit prototypes or financial models, are unrelated to architectures, because architecture is strictly about linking functions and components, ensuring that the final product structures supports the intended functionality. Okay. So the correct answer for this particular question is option B, functional elements into physical components is the right answer. And you may go through this slide. Now moving to ask the next questions. Question number 18. Okay, so the 18 is, which of the following is a consideration in modular product architecture? Is it ease of assembly, ability to upgrade components, or product variety and customization, or all of the ever? What is the right answers? Okay. Question number 17. Yeah, please go through this slide. So basically the modular architecture is designed with flexibility in mind. One consideration is ease of assembly, since modules can be built independently and later integrated. So this reduces the manufacturing time and complexity. So another key factor is upgradability. Modular systems allows the customers to replace or upgrade individual components without changing the entire product. So for example, modular smartphones allow camera or battery upgrades. So finally, modular design supports the product variety and customizations. So customers can choose a different model combinations to suit their preferences. So these three considerations together, assembly, upgradability and customizations, make modular architectures powerful in the modern design. Now moving now you may see the explanation part in this particular slide. Okay, and so option D is the right answer. All of these are the correct answer, and you may go through the explanation part, which I have already written here. And yeah, so moving towards the next slide. So next one is question number 19. So in a functional modeling, flow are usually represented by what? Arrow connecting function block, or dotted line showing communications, or table of input or output values, or pie chart. What is the right answers for this particular questions? Okay. Okay, provide me, let me provide you the explanation. So in functional modeling, flows are always shown as arrow connecting function block. So the arrow carry energy, material or informations, and their directions indicates the transformations path. For example, in vacuum cleaner, electricity flow into convert energy, sections power flow into transport material, and dust flow into a collect materials, right? So these arrow based representations make it easy to visualize dependencies and the overall transformation chain. So without arrows, the diagram would lose its clarity and meaning. So other formats like table or charts can provide supporting data, but not replace the arrow as the core representation of flow in functional modeling, right? And now you may see the the correct answer and explanation part in this slide. So as I've written here, the arrow connecting functions block is the right answer, and you may go through this small explanation parts by yourself. So please go through this slide. Okay, now moving towards the next slide, question number 20. So which of the following best describe the conceptual design? Is it converting function into physical form through architecture? Okay, or manufacturing the product after testing, or marketing the product to target customer, or eliminating the customer needs that are not profitable? What would be the right answer? So the conceptual design is the stage where abstract functional models are converted converted into a product architecture, and it answers the how questions. How will the identify the functions be realized physically? For instance, if functions requires transport heat, conceptual design decides whether it will be done through a fan, a heat sink, or a liquid cooling. So it is not about manufacturing, marketing, or eliminating customer needs. So those are later or external process. So conceptual design focus on bridging functional with engineering solution. So this stage is critical because it shapes the direction of the entire product. So a poor conceptual design leads to inefficiencies downstream, while a strong one ensures the alignment between customer needs, functional models, and physical architectures. Okay, and now you may see the correct answer. Just a minute. So option A is the right answer, converting function into a physical form through architecture, and you may go through this slide. So yeah, thank you so much, thanks a lot. Hope this particular discussion will be helpful for your better understanding of the week 7 lecture. Okay, so please go through this video, and it will be really helpful for your examinations point of view. Okay, so thank you guys, thank you so much. And if you are watching this video later, please try to come and join the live session. That will be really helpful for me as well. So thank you guys, thank you so much, bye bye.